Okay, in this video I'm going to continue on with exercise 4b of the book Fundamental Applied Mathematics. We're on page 107 and the question is 27. It reads, an aircraft flew due east from P to Q at u1 km an hour. Wind speed from the southwest was v km an hour. On the return journey from P to Q, due west, the aircraft's speed was u2 km an hour, the wind velocity being unchanged. If the speed of the aircraft in still air was x km an hour, where x is greater than v, show by resolving along the perpendicular to PQ or otherwise that u1 minus u2 is equal to v root 2. So on the left here in this box I've just put in the information regarding VPQ, and in the centre I've drawn my Cartesian plane. So we know that the wind velocity vector here is blowing towards the northeast, and that means of course it's angled at 45 degrees to the horizontal. u1 corresponds to the plane going in an easterly direction for leg 1, and u2 corresponds to it going in a westerly direction for leg number 2. So of course the next thing we need to work out is where VPQ is. Of course in this case that means the wind is in a stationary frame of reference. So in order for us to go, we'll say, in an easterly direction, we need to have a 0 j hat component, which means we need to aim our VPQ vector initially in this direction in order to cancel out our j hat component. And also, so we'll say this is VPW for u1, and then on the return journey we need to go this direction, so this is VPW for u2. And just to resolve these vectors, if I call this angle here theta and I call this angle here theta as well, then it will say VPW for u1 is just going to be, it's going to be x times the cos of theta I hat minus x times the sine of theta j. And similarly this one here is going to be negative x times the cos of theta I hat minus x times the sine of theta j hat. The velocity vector of the wind is going to be v times the cos of 45 I hat plus v times the sine of 45 j. Alright, so the cos and sine of 45 each are 1 over root 2. Now the next thing you need to notice, of course, is that VPW is equal to VP minus VW. So what I've done is this, and I've just worked ahead a small bit. So here, what I've written is VPW is equal to VP minus VW. Number 1 is on the outward journey, number 2 is on the return journey. So if you'd like to pause the video there for a moment, do so. But this is nothing we haven't seen before. Now we're asked to find u1 minus u2 is equal to root 2v. Now I'll be quite honest, I haven't got this answer. I've got an answer that u1 plus u2 is equal to root 2v. So it's either that I'm making an error, which if you see, please point it out to me, or if I'm not, it just means there's a typo in the question. So for that reason I'm actually only going to do this part of the question. So like I said, we have two parts, or two equations, 1 and 2. And in this, if you look here, in this part of the equation, there is no x component. So in both cases I'm going to solve for x, here and here. Alright? Now if you look also, there is a 0 j hat component here. So as a result, I'm actually going to just work with the I hat components for the start and see what happens. Alright, so we're going to get the following. We're going to get that x times the cosine of theta is equal to u1 minus v over root 2. So if you want to rearrange that for x, you're going to get that x is equal to u1 minus v over root 2 over cos of theta. Like so. Next, if we rearrange over here, we're going to get negative x times the cosine of theta is equal to u2 negative v over root 2. So once again, where we rearrange this, we're going to get x is equal to v over root 2 minus u2 over cosine of theta. Now of course these two equations here, which I'll outline in red, this one and this one, they're clearly equal to each other. So if I let them equal to each other, the cosines will just disappear. And what we'll be left with is as follows. So we're left with that u1 minus v over root 2 is equal to v over root 2 minus u2. And you get u1 plus u2 is equal to 2 times v over root 2 or root 2 times v. Now of course the answer given in the book tells us this should be a negative sign here. Now I don't know the answer, I don't know what the supposed answer is. So for that reason I'm not actually going to continue on. I'm going to leave it at that. If you've seen that I've made a typo or a serious mistake, please point it out to me. But other than that, thanks for watching. Please pass it on to your friends and subscribe to my channel.